I would like to present the work done by the research group from University of Ljubljana. Members of this group are Mitja Plos, Tamara Šulikoj, Žiga Krofel and me. My name is Goran, Turk. We have two main goals in this part of our research. Firstly, we want to estimate the mechanical properties of old timber. And secondly, we want to use these observations to establish basic knowledge which will be used to set up grading procedure for old timber. In order to do that, we have looked at three different structures in Slovenia. The first one is a 90 years old bridge over the Sava River in Slovenia. It was made of oak and spruce timber. We've taken 50 oak beams and tested them. Second structure is the roof of a historical building which is a part of our faculty. The roof is being replaced this year, and so we could save some beams in order to test them later. The third one is a small terrace roof of a typical Slovenian house, and we have done this research during the last year. If we want to use reclaimed timber for structural purposes, we run into a problem. There is currently no option to grade this timber based on any standards. The existing standards are good for new timber, but there is nothing there for used timber or old timber. With new timber, we have two options of grading, visual or machine. For old timber, we could use both, each of them, or both in combination. And we could even think about grading based on the intended end use of the old timber. Before we cut into the wood and reshape it, we have to ask ourselves, what can this piece of wood be most useful for? What is the most we can get out of it? What will be the price of it? Is there a customer that wants to use it as is? What will be the end use for it? What will be the expected load on it? Will the timber hold this load? Can we estimate the strength and stiffness accurately enough to be on the safe side even after another 30 or 50 years? These are all different questions that require an answer. With reclaimed timber, we often have parts with missing cross-section due to previous joints. The extent of these notches might differ very much, and sometimes it would be a shame to cut out all the material. Local rot or other damages have a similar effect. We could decide to make shorter beams with the cross-section intact, as is shown in this figure. Or we could opt for a smaller cross-section, but to use the whole length of the beam. To evaluate the effectiveness of visual grading generally used in new timber, but now used on old timber, we measure various visual parameters based on different European standards. Those are dimension, knots, slope of grain, ring width, different kind of pit, fissures, and then different kind of deformation like crook, cup, bow. Of course, discoloration and the presence of insects. In addition to that, we have acknowledged some other things. First, with recovered wood, some of the characteristics such as knots, fissures and insects need to be measured again. For example, fissures are now much bigger and longer than they were when the wood was new. In addition, rot, nails, notches, water damage, fire damage need to be measured and taken into account. We also added an additional item, and that is we call it best used for, with subjective consideration of the person who is evaluating the timber element. When we measure the knots, we also come across rotten knots, which is not the case with new wood. And there is another question we would like to answer. Are rotten knots different from sound knots mechanically? How much different? When we think of rot, we need to ask also if we should reject those elements altogether, or can we cut out of rotten part and use the rest of the wood? As you can see, we have easily cut some parts that were completely rotten from the beam in question. We could also disregard the rotten part in the structural calculation and use the beam as a whole. Sometimes this character of wood might be desired. Plus, in this case, we would be storing more and emitting less carbon. Nails. In structural terms, the presence of nails is not important, but they are a major obstacle, the major issue for further production, as they damage the cutting knives. And actually, we don't really like them in timber. But they are there, and sometimes, I should say often, the nails are too corroded to get them out. To still use this wood, an option might be to hammer the nails further deeper and brush or sandblast the elements to get a cleaner surface finish. Of course, this can only be done when we use the timber as is. According to some visual grading standards, small insect holes are allowed in new timber. But of course, with new timber there are usually not many. But with old timber, the extent and the effect of it can be much greater. Now we are switching to machine grading, to measuring by machines. Different instruments were used to see if the correlation between the measurements and the mechanical properties are similar to those used in new timber. We measure the first eigenfrequency with a microphone, laser vibrometer, and ultrasound. In addition, we also did some drilling with two different machines. One measured the resistance of drilling, and the other is used to measure local density from the drilling residue. Finally, we perform or plan to perform destructive testing. In the case of beams, we perform 4-point bending test. The bending test of spruce beam is shown here. We are now in the process of testing oak beams. Those are the beams measured in flat face position. The displacements are measured by the GOM system using the high resolution photographies.
Perfect.
At the end, I would just like to acknowledge all the partners and the funding institutions listed here. Thank you.